Over 45 years, NASA has revealed some of the most shocking and unexpected secrets of interstellar space. Not only did the spacecraft discover the massive storm on Jupiter and the rings around Saturn shortly after its official launch, but NASA has also recently warned the world of a strange and seemingly impossible discovery from Voyager 1. This revelation has left scientists both confused and worried. The conflict arises because the information coming from the system that controls Voyager 1's operations does not align in any way with the spacecraft's recent activities. What could this impossible discovery be, and what is the way forward from it? Join us as we take a trip to outer space and uncover what has been happening in our universe. Voyager 1's unexpected signals have emerged as the probe has been traveling through space for 47 years since its launch, still exploring regions beyond our solar system known as interstellar space. Recently, however, it has developed an issue that has puzzled the team of scientists and engineers who monitor it from Earth. Despite its age and its distance of 15 billion miles from our planet, Voyager 1 continues to function well. It can receive commands sent from NASA, carry them out, and collect and transmit scientific data back to Earth. However, there is a particular issue with one of its key systems, and the gravity of this issue is enough to cause concern. This system, called the Attitude Articulation and Control System, AACS, controls the spacecraft's orientation in space, ensuring that its high-gain antenna remains pointed toward Earth to send data back to NASA. However, the data readouts from this system do not match up with its recent activities. What Voyager 1 is actually doing remains uncertain. While it seems to be operating correctly, the information sent back by the AACS appears random or even impossible. One of the challenges in handling this issue is the vast distance between Voyager 1 and Earth. Since Voyager is in interstellar space, it takes a signal or light 20 hours and 33 minutes to travel one way, meaning that sending a message to Voyager and receiving a response takes over 41 hours. Despite this delay, the team has determined that the AACS is likely still functioning, as the system's unusual data readouts have not yet triggered a safe mode. In safe mode, only essential operations are carried out, allowing engineers to diagnose and address issues that could threaten the spacecraft. Interestingly, the signal from Voyager 1 remains as strong as ever, indicating that its antenna is still aimed accurately at Earth. Currently, the team of scientists and engineers is investigating whether the AACS itself is generating erroneous data or if another system is causing this problem. They aim to understand why the data from this instrument does not align with Voyager's actual operations. The team studying Voyager 1 is working to uncover the nature of this puzzling issue, as they cannot yet determine if it will impact the probe's ability to gather and transmit scientific data. This uncertainty stems from a NASA release in 2022. Suzanne Dodd, project manager for both Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in Pasadena, California, noted that this type of mystery is expected at this stage of the Voyager mission. Dodd explained that Voyager 1 is almost 45 years old, significantly surpassing the mission planner's initial expectations. It now traverses interstellar space, an area of high radiation where no other spacecraft has ventured, presenting substantial challenges for the engineering team. Despite these challenges, Dodd is confident that if a solution exists for the AACS issue, her team will find it. If they cannot identify the cause, they may have to adapt, possibly by modifying software or using a backup hardware system if the problem source is found. Voyager has sustained operations by utilizing backup systems over the years. For instance, in 2017, it successfully used thrusters first activated during its planetary encounters in the 1970s. These thrusters had been inactive for 37 years but still functioned when needed. Given the probe's age and limited power generation, many subsystems and heaters have been shut down over time to conserve power for critical systems and scientific instruments. While Voyager 1 currently faces this issue, it reminds us of one of its most historic moments, its arrival at Jupiter in 1979. Voyager 1 made many important discoveries that transformed our understanding of the universe. Understanding Jupiter, the giant planet, Voyager 1 discovered that Jupiter has a ring system. Before this, scientists thought only Saturn had rings. Jupiter's rings are faint and made mostly of tiny dust particles, difficult to see from Earth, but Voyager 1's close-up photos revealed them clearly. Voyager 1 also studied Jupiter's Great Red Spot, a massive storm larger than Earth, raging for at least 400 years. Detailed photos of the red spot helped scientists learn about its structure and behavior, showing strong winds moving in opposite directions around its center and revealing it as a complex weather system. In addition to Jupiter's rings and the Great Red Spot, Voyager 1 uncovered several other fascinating aspects of Jupiter, including clouds, smaller storms, lightning, and auroras similar to those on Earth. These pictures helped scientists better understand Jupiter's atmosphere and its similarities and differences to Earth's weather systems. After exploring Jupiter, Voyager 1 continued through the solar system, reaching Saturn in 1980, where it made equally intriguing discoveries about Saturn, its moons, and its massive ring system. One notable discovery was identifying new moons around Saturn, which added to the known list of its natural satellites. These moons varied in size and composition, expanding knowledge of Saturn's moon system. Voyager 1's detailed study of Saturn's rings revealed that they comprise countless particles ranging in size from tiny grains to large boulders orbiting Saturn in an intricate ring system. The spacecraft's observations showed that Saturn's rings aren't solid but are made up of multiple ringlets, gaps, and divisions shaped by gravitational interactions with Saturn's moons, creating complex and constantly shifting patterns. Voyager 1 also captured stunning images of Saturn's moons, including the largest, Titan, providing insights into the geological features and surface characteristics of these moons, which helped scientists understand their origins and evolution. Voyager 1 didn't just observe the physical characteristics of Jupiter and Saturn, it also took a closer look at two of the largest moons, Europa and Enceladus, uncovering signs that both may have hidden oceans beneath their icy surfaces. Europa, one of Jupiter's largest moons, has intrigued scientists for a while due to hints of a subsurface ocean under its frozen crust. Features like cracks and ridges suggest that gravitational forces from Jupiter and nearby moons might be causing tectonic activity beneath Europa's ice. This ocean possibility excites scientists because where there's liquid water, there could be life. If Europa's ocean contains hydrothermal vents similar to those on Earth, it could create conditions suitable for tiny life forms. Enceladus, one of Saturn's moons, also has a hidden ocean beneath its icy exterior. The Cassini spacecraft, during its mission around Saturn, detected jets of water vapor erupting from Enceladus, suggesting water beneath the surface occasionally bursts into space. These water jets contained organic molecules, or life's building blocks, and Cassini found evidence of hydrothermal activity on Enceladus' seafloor, further suggesting there might be a dynamic environment under the ice. These discoveries on Europa and Enceladus have scientists considering the possibility of life beyond Earth, and NASA has plans for missions like the Europa Clipper to explore Europa, as well as future missions to investigate Enceladus more closely. Voyager 1's discoveries didn't stop with Jupiter and Saturn's moons. NASA has revealed even more intriguing information about these planets. Meanwhile, Voyager 2, the twin spacecraft of Voyager 1, is also operating in interstellar space, currently 12.1 billion miles, 19.5 billion kilometers, from Earth, farther than Neptune, the farthest planet from Earth. Both Voyager 1 and Voyager 2, launched in 1977, have exceeded their original missions, now gathering data from interstellar space, which helps scientists understand the heliosphere, the bubble created by the Sun that stretches beyond the planets in our solar system. In 2018, Voyager 2 made a landmark discovery when it became the second human-made object to enter interstellar space, providing insights into the Sun's bubble-shaped boundary. On November 5, Voyager 2's data revealed that it crossed the heliopause, the boundary where the hot solar wind from the Sun meets the cold plasma of interstellar space. The crossing showed a decrease in solar wind particles, confirming its entry into interstellar space over 11 billion miles from the Sun. Unlike Voyager 1, which crossed the heliopause in 2012 without a functioning plasma instrument, Voyager 2's intact instruments allowed scientists to gather more detailed data. This revealed that particles from the solar wind and interstellar winds mix across this boundary, and a solid interstellar magnetic field stronger than that detected by Voyager 1. Scientists continue studying data from Voyager 2 to understand the Sun's interactions with interstellar space, as shock waves from the Sun can pass through the heliopause into the interstellar medium, similar to how shock waves from supernovas move through space. Early data from Voyager 2's crossing is building a detailed picture of what happens in the space between the Sun and the interstellar medium, offering insights relevant to other star systems. By comparing Voyager 2's findings with those of Voyager 1, scientists gain valuable perspectives and are hopeful for another interstellar probe to gather even more data. Voyager 2, similar to Voyager 1, has made significant discoveries, including observing moons around Jupiter. In 1979, it spotted a small moon called Adrasti, marking the first time a moon was found using images from a spacecraft in space rather than a telescope on Earth. Adrasti, named after a figure in Greek mythology, is unique as it completes an orbit around Jupiter in less time than the planet's rotation. It lies on the edge of Jupiter's main ring and is believed to be a key source of the dust that composes the ring. Although the Galileo spacecraft observed it in the 1990s, we still know little about its composition and appearance beyond its size and the fact that it always faces Jupiter. Adrasti was discovered by scientists David Jewett and Edward Danielson, who found it as a tiny dot in photos taken by Voyager 2 on July 8, 1979. The moon received its name in 1983. The Juno spacecraft, which reached Jupiter in 2016, might eventually capture some images of Adrasti, although its primary mission is to study Jupiter itself. Adrasti, the smallest and second closest of Jupiter's inner moons, orbits the planet at a distance of about 129,000 kilometers, approximately 1.86 times Jupiter's diameter. It has an almost circular orbit and stays close to Jupiter's equatorial plane. Its orbit is smaller than Jupiter's synchronous orbit radius, meaning it is gradually moving closer to Jupiter and may one day crash into it. If Adrasti is as dense as another moon, Amalthea, its orbit would actually be too close to Jupiter to remain intact. However, its current distance from the planet has allowed it to stay in orbit. The Voyager probes, initially expected to last only 5 years, have been operating for 42 years, defying expectations thanks to engineers dedicated to keeping them functional. Engineers have devised new plans to extend Voyager 1 and 2's missions, enabling scientists to continue receiving critical data from an unexplored region of space. The main challenge in keeping these spacecraft operational is maintaining enough power for their scientific instruments and heaters. Both are over 11 billion miles from the Sun, where temperatures are extremely low, so the heaters are crucial for their survival. The spacecraft's power systems have decreased in efficiency, producing about 40% less power than they did at launch. The probe's thrusters, which release small bursts to maintain orientation and communication with Earth, are also aging. Voyager 2, for example, recently activated thrusters last used during its Neptune flyby in 1989, following a similar maneuver by Voyager 1 in 2017. Voyager 2 has been prioritized for receiving these new updates as it collects more data due to an additional functioning instrument not present on Voyager 1. Recently, engineers turned off a heater on Voyager 2 for its cosmic ray subsystem, dropping the instrument's temperature to -74°F. Despite this, it continued sending data, showcasing its resilience. As of now, scientists can still communicate with Voyager 2, though it takes about 16.5 hours for data to reach Earth. With a new plan to conserve power and maintain orientation, engineers expect both Voyager spacecraft to keep transmitting data for several more years. The information they have gathered is invaluable and has informed NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch this year. Despite their age and vast distance, the Voyager probes continue transmitting crucial data on the space environment beyond our solar system, exemplifying their innovative design and the dedication of the engineers and scientists behind them. Looking to the future, the Voyager mission might still uncover more about interstellar space. Even if they eventually lose power, they will drift silently, carrying a golden record with Earth sounds and images like a time capsule of humanity's achievements. Although they might one day fade into the vastness of space, the Voyager legacy of discovery will endure, inspiring future explorers and scientists. What do you think Voyager 1 and 2 will find or observe next? We would love to know in the comments. If you enjoyed this video, don't forget to like, share with your family and friends, and subscribe to our channel for updates.